Here is something you've probably never thought about in JavaScript. Why do you need to await twice when working with the fetch API? You have the first await where you make your fetch request, then you have another await when you want to get the JSON data. Or if you are using then you have fetch.then, you have your response, then for the JSON again you have .then before you get the data. Well, this comes down to how servers send data to clients and how the fetch API allows you to read that data. So here I have three APIs which we'll be using to test. The first one is this JSON placeholder, which is a free API you can use online. The second one, we have a GitHub public API where we can read the commits from Facebook. And then we have this third API, which is a local server that I have running. So let's start with the first one. We make our fetch request, right? And then we wait for the JSON. Then we can read that data. And if I come here, you can see I have the data here. So what if I remove this await and then I just do response.json call? If I refresh, now I have a promise. So this is a promise that resolves to that data. But what exactly is this promise even doing behind the scene? We're going to have a look at that. But this is not just for response.json. This is also for response.blob. It returns a promise. This is also for response.text. It returns a promise. Let's take this back to JSON. So the first thing you should know with this fetch API is that the first time you make your fetch request, you already have access to the headers and to the status of that request. You don't have to await to get any of that. So for example, if I do const prop of response.headers, I think I can be able to do console log prop. Yeah, you can see when I refresh, I have the cage control header, content type header, expires header, and the pragma header. And I also have access to the status, response.status. And if I refresh, this is a status of 200. So I already have access to the header and the status, but the body of the response is something that I cannot access immediately. Let's try that. If I do console log response.body, now if I refresh, you can see it doesn't show me what the body is. It just shows me this readable stream. Now this readable stream is where you get to understand why you have to wait twice. The readable stream interface of the streams API represents a readable stream of byte data, and the fetch API offers a concrete instance of the readable stream through the body property of a response object. But let's learn more about this fetch API. As you see here, request and response bodies are actually readable stream objects, and whenever you read them, you are streaming the content. This is good for memory efficiency because the browser doesn't have to buffer the entire response in memory before the caller retrieves it using a method like JSON. So what is happening here is that the server has already sent the header and the status, but the body is not sent immediately. The body is sent as a stream, and think of a stream as the server keeps sending data to the client until it is done. So this depends on how big the body might be. If the body data is a lot, the browser might send, for example, 5 chunks. That's what it's called. In the stream, it sends the first chunk, sends the second chunk until it gets to the 5th. If it's a data that is not really large, then the server might just send 1 chunk in that stream. But these chunks comes after the client already has access to the header and to the status. And we can actually read that chunk ourselves. So basically what response.json is doing behind the scene, or response.blob or response.text, is that it is reading that stream and processing it for you. But we can actually read it ourselves. Let me show you how. So here we're going to get the reader, which is on response.body.getReader. Then I'm also going to get a text decoder so that we can make sense of the data we get from the stream. I'll actually show you what that data looks like before we decode it. And then here I can have a while loop where I read the stream until I get to the end of the stream. I'm just going to have while true. Then here I'm going to destructure the reader of the stream where I have value and done, and then I await reader.read. Now this value is going to be the chunk that I get at that particular time from the stream. This done is going to be true when I get to the end of the stream. So here I can say if done, then break out of the loop so I don't have an infinite loop. Now I'm just going to do console log received chunk so that you can see what that chunk looks like. Console log the value here. So now if I come here and I refresh, you can see we have just 1 chunk, which is of this type uint8 array. But this is because I'm just fetching a simple request. So this stream just had one chunk. But then let's say I try to get this URL too, which has a longer response body, then maybe I might get more than one chunk. So I'm going to change this to URL 2. And now if I refresh, I have 3 chunks here. If I also refresh, I might get just one chunk, and that's because sometimes the server is not implemented to send a fixed number of chunks. It can depend on various factors like even your network connection. So in this case, the GitHub server was able to send everything in one chunk. If I refresh again, one chunk. If I refresh again, we have 2 chunks here. So this is what the chunks looks like, but we cannot make sense of this data. So this is where I can decode the chunk. So here I can have decoded. This is my decoder dot decode. I want to decode the value, and then I have this option with stream true. Here, when I get the received chunk, I can now console log decoded instead of the value. So now if I come here and I refresh, you see we can now make sense of the chunk that we get. So this is the first chunk, which starts from here and it keeps going. And I think in this case, I have another chunk here, keeps going. So we have 2 chunks. So we just had 2 chunks in this case. The reason why I have this while loop is so that I can read the stream until I get to the end. But if I don't read this stream multiple times, I might only get one chunk. Let me show you that. I'm just going to copy everything from here, come out of this while loop. So let's just say I read the stream once, I get the decoded, and then I just do console log decoded. So you're going to see what part of that chunk looks like. So when I refresh now, I get this chunk, and if I go to the end and I copy this, let's just say I go to a new file. I'll just have this file as demo.json. Now when I paste this chunk here, you can see that the chunk starts with a square bracket, but we don't get to the part where we see the square bracket at the end. That's because we stopped reading the stream even when the stream still had more chunks to send to us. So coming back here now, I can get all the chunks I need and put it in this variable. Let's just say the variable is an empty string. Then I have my while loop where I keep reading the stream until I get to the end. And when I get the decoded, I'm going to append that to the result variable. So I have decoded here. And then at the end, I can now console log results. So I've read to the end of the stream. I've concatenated all the chunks together to have the full body. And if I refresh now, I have the full body. I can copy this now, come to this demo.json, paste everything. And now at the beginning, you can see we have the open square bracket. We have all the chunks. Maybe in this case, it was even up to 5 chunks, who knows? And then we get to the end and we have the square bracket. Now we have been able to read everything. So this is what response.json is doing behind the scene, reading through the stream and then passing the body to JSON. Response.blob would read through the stream, then convert it to blob. Response.text would read through the stream, then convert it to text. So if I come here now to get the data of the response JSON, it helps us do all of that so we don't have to do it ourselves and we just have access to the JSON. So if I refresh, okay, now I have an error, failed to execute JSON on response, body stream is locked. So the reason why the body stream is locked is because we have a reader open here. So if I should do console.log response.body, you see that in the readable stream, we have locked as true. That's because we have this get reader called here. Now if I should comment this line and I refresh, you can see that the locked is now false, and so this JSON call down here can now have access to the stream and read from the stream. But currently this is a promise, so I need to have my await here, and after reading through the stream I can now have access to this JSON array. So just like we saw in the fetch API, the reason why we have this stream technique is for memory efficiency, because in the case where you are getting large body data from the server, then the server would have to process everything at once, which requires a lot of memory. But by getting that data in chunks, the browser can process one at a time, and just like we have with response.json, we can now get the full JSON. So the first request we make, we just get access to the response object where we can see the status, the header, and the body which has the readable stream, and the second await is where we now read through that stream. But there are actually cases where you might not want to just get the full JSON, but you might want to read through the stream like we did here. And a good example here is platforms like ChatGPT, Perplexity, or all of these AI platforms. For example, ChatGPT here, if I should say, who is Deeecode, it sends this request to the server, but instead of just giving me a page of who Deeecode is, we now have this where it begins to bring the response one at a time, either one character at a time or one word at a time. And we can actually replicate this. So in my HTML here, I have this div with an ID of GPT response. In my code, I can get that GPT response element. So here, when I get the decoded, I can now say that GPT response element dot inner text, and then I can add that decoded text here. So as I get the data from the chunk and decode it, I put it on the DOM. Now this might not work as smoothly as ChatGPT, and I'm going to fix that, but let's see what this looks like. So if I minimize this a lot, if I refresh, oh, reader is not defined. Oh yeah, reader is not defined because we logged it here. Okay, and I'm also going to comment this part here. So if I refresh, everything comes one time as a chunk and they are added to the DOM, but we don't really see it. It feels like everything just added at the same time. But this is because the first chunk was already a lot of characters, so that already filled the screen before the other chunks came in. But I have my own server where I'm able to control how many chunks is sent per time. So this is my Node.js server. I'll put this on the right here. I already have the code for it just to save time. So on my API, when you go to data, I'm going to read this file, data.txt. This is what data.txt is. It's just some lorem ipsum random data. Then what I do here is to first set the header and the status code. So 200 with a status code of content type text plain. So when the client makes a request to this server, even if it hasn't gotten the complete body yet, it can already read this header. Then here I now create my own stream. This is how you do it in Node.js. It might be different in a different server-side language. So I have my create read stream where I want to create a stream by reading this file, the data.txt, with an encoding of UTF-8. So for the event of readable, which means when there are data available from the stream that we can read, then we have this while loop where we first get a chunk from the stream. Here we're reading 8 bytes at a time, and then in this while loop we check that if this chunk is not null, I'm going to comment this part for now, we have res.write chunk. So we're going to write to the stream in that response so that the client can read from there. But in the case that the chunk is null, that means we have gotten to the end of the stream. And on stream.end, we can now call res.end. Now I had to change this to URL3 to point to my local server. So now let's see how this works. If I refresh now, everything just comes in at once. So you don't really see the chunk coming in one at a time. But if I come here now and I just add this fake sleep, let's add a fake sleep of 1 second. This means a chunk is sent after 1 second until we get to the end. Now if I come here and I refresh, look at what we have. Let me zoom in. 8 bytes coming in, 1 chunk at a time, and it is coming in like this, but this feels too slow. So let's make this hundreds millisecond. Now if I refresh, you see it's coming in 100 millisecond, and we have something like ChatGPT going on here. Let's reduce this 8 bytes to 1 byte, which is like 1 character. And if we refresh and it has this, one thing I noticed is that when I use 1 byte, it keeps skipping the spaces. I don't know why that's the case. I would read up on it after this video, but let's just keep this at maybe 4 bytes. So at 4 bytes, we have something like this. Be a bit faster with 10 bytes. And now we have 10 bytes of data coming in here. So what you notice in all of this is that even though all of this is still loading from the server as a stream, the Fetch API already has access to the status code and the headers. If I come here and I do console log response.status and I refresh, you can see it already has access to the status of 200, even though the stream is still coming. So in this case, we can read the stream 1 chunk at a time and do whatever we want to do with it. But if we should do response.json like we did before, now it's going to wait until response.json has made sense of all the data that it got from the stream. So let me comment this part here. So now if I refresh, so now you see that response.json is reading through that stream, waiting until the stream gets to the end before it displays the data. And this is probably going to take some time. So I'm going to fast forward this video to the point where response.json is done. So you can think of this as what ChatGPT does. Instead of ChatGPT showing you a blank page until all the data it wants from the GPT is streamed, it just shows you one at a time. I mean, that also makes the user experience better because you're actually seeing something on the screen. Okay, we finally get an error which says failed to load resource incomplete chunked encoding. Well, I guess what I'll just do is I'll reduce the text in this data.txt. Let me just reduce it to one line. Instead of using response.json, I'm going to use response.text because this is actually a normal text, not JSON. Go to the console. Something happened with the server. Oh, I actually get an error here. So something must have happened with so it got to the end of the stream, but then it tried to stream a null value. But I thought I already told you not to stream a null value. I don't think this is the problem though, but I'm supposed to have a let chunk variable like this. So I think it has something to do with maybe variable hosting. I was supposed to have the chunk variable first before I assign it to this. So when we get the data here, I'm going to get this GPT response. I'm just going to put it here where I add the data. So now when I refresh, you can see that we wait until we get everything from the stream before we put it here. That's what the response.text does. It gets to the end of the stream. But if we don't want to do that, then we can read the stream ourselves, and then it comes one chunk added to the DOM and so on. Now, I'm not saying this is exactly what ChatGPT is doing. Like maybe they have one fake sleep function there, or it's just the way the server works. I'm not really sure, but all of this is just to demonstrate these concepts like readable streams, you manually controlling the chunks that are sent to the client, and on the client, either waiting until you get every chunk with response.json, or you read the chunk yourself and do something with that information. But I hope that with this video, you have now gotten to understand why you have to wait twice. The first wait is to get the response information like status and header, and then the readable stream. And then the second wait is so that you can get the complete body, because the complete body is not sent immediately with the response. It comes in a stream, and one of the benefits is for memory efficiency. And then you can read through that stream, and then you get to the end of the stream, you have your processed data, and you can now do something with that information. Please give this video a like and subscribe for more videos like this where we go into the whys in programming.